solve cubic equations, first thing we want to do is actually graph these two. So how many critical points do you need?
3. 2 1.
2 endpoint.
If you have 2 endpoints, what you gonna make?
Whatever.
How many do you need? I told y'all the other day you have to have at least 5. Because 2 makes a line. And in a cubic function, the 3 in the middle usually make a line. And so you won't know how it curves, you need 5. So you're going to plug this in your calculator, get 5 critical points off your calculator. Looks roughly like that. So I plotted this one wrong. But it has 5 critical points. One right here. That's 1, 2, 3, 4, 5. So I can get the shape of the curve that way. Okay, so we kind of talked about this a little bit yesterday. But if you look at the top, it's asking us to state the number of real zeros. Just how many real zeros does this function have? 1. What is a zero?
Oh,
An x-intercept. This one has 1. Real zero. And that's all they asked me for. They asked me the real zeros. It has 1 real zero. But we have learned and talked about the fundamental theorem of algebra says that the number of total zeros is based on the degree. And what degree is this?
3.
So I should have 3 total zeros. So if only one of them is real, what does that tell me about the other 2?
Imaginary.
They're imaginary. So all this asked me for was how many reals, but I'm going to write into imaginary. Alright, so let's do the same thing for number 2. Excuse my terrible graphing skills. How many real zeros does this one have? 3. You can see all 3 of the zeros on this one. Now, if you go look at I'm going to look on the graph on my calculator, not mine, so I'm a terrible grapher. It looks like for sure that this one, and I know from my table actually when the critical points I plotted, that this one actually is on a grid line, easy to find. But these other 2 are between grid lines. They're real, they just happen to be fractions or decimals. But you can see them. As long as it crosses the x-axis, they are real zeros. Okay, so at the top of the page, we're calling them zeros, or x-intercepts. But when we get to the middle of the page here, we're going to start calling them roots, or solutions. Zeros, x-intercepts, roots, solutions, they're all the same thing. They're the answers to these equations. So that's what we're looking for. When it says find all roots, they want us to find the answers to this equation. I could plug this in my calculator and find all of the places where it crosses. Those would be your roots. Instead of doing it that way, let's go ahead and actually algebraically find them. So if I'm looking at this, I need to factor it. What would be my first move?
Factor out
X
x.
is,
Factor out an x. Very good. So if I do that, inside I will be left with x squared plus x minus 6. So far so good? Just undistributed that first x. Alright, so now when you get down to this point, I have factors. And remember we were talking about once you have factors, you can set your factors equal to 0. So this one can be set equal to 0, x equals 0, and x squared plus x minus 6 equals 0. So I already have one answer. Once I did that, I found myself one of my roots, this one right here, because x equals a number, 0. But this one, I have to continue to factor. So, how does that factor? Anybody know?
X plus 3x minus 2.
X plus 3x minus 2. Which means each of those pieces could be set equal to 0. So that tells me x equals negative 3 and x equals positive 2. So there are all 3 zeros. So now I just did algebraically what I could do in my calculator. So let's plug it in our calculator and see if in fact those are all the zeros. So you can see right here the negative 3, and there's the 0, and there's the 2. Everybody good? Alright. So let's try the next one. I'm going to factor out, in this case I can factor out an x. Once something is factored, each of its factors can be set equal to 0. So x equals 0.
Where do you get the 1 from?
Oh, because if you take, remember factoring is just division. So if I divide this by x, I get x squared. If I divide this by x, I get 2x. If I divide x by x, you get 1.
I think, it looked like pre-calc to me, but I think it's calculus.
Oh, yeah, calculus.
Okay, thank you.
Alright, so I found one of my answers. Again, this one passes through the origin now. Somebody asked last period when we were doing this, are they all going to be that way? No. But for starters, it's a good place to start with them passing through the origin. Because remember when we studied the parent function passes through the origin. So they're just stretching it and stuff right now, but they won't usually pass through the origin. It's just a good place to start. Okay, but this piece needs to be factored. Now, how does that factor?
X minus 1, X minus 1.
X minus 1, X minus 1.
It's a double.
Good. It's a double root because that would give me x equals 1, x equals 1. Well, that is 3 roots. I mean, the fundamental theorem of algebra tells me that this is cubed, so I should have 3 roots. And I do. 1, 2, 3. But these two are the same. They're a double root. So graphically, when we look at it, what is that going to look like?
It's just gonna go there.
It's going to what?
Go there at once.
It just goes through it once, but what does it do? What's the graphic behavior at that place 1? Why is it a double root? What's happening there?
that a maximum?
It could be a maximum or a minimum. It's sitting right on the x-axis. So it's gonna touch, it does what we call bending. It's gonna touch and turn, we call it a bounce or a bend or a touch and turn, right on the x-axis. So let's look at it. We'll have to zoom on this one, I think, in order to see it, but because when you first look at it on the standard window, it almost looks like it doesn't do anything. But I'm gonna zoom in. There you go. I'm gonna zoom in a little more. Okay, so if I zoom in on it, you can see it passes through 0, so that's one of your zeros, and then it touches 1 and then turns around. That's why it's a double root. It bounces there. When they were quadratics and they were double roots, remember they sat right on the axis. Either way, up or down. So that's a double root. When you have a double root, you only have to write one of the double root, you only have to write it down one time. Alright, so looking at number 5, again we've got an x we can factor out, so let's factor that out. Once you have factors, you can set each factor equal to 0. And that gives me one of my 3 roots. Alright, so then I get this, x squared plus 4x minus 34. Anybody know how that factors?
Can it factor?
There are no factors of 34 that combine to give you 4. So how do I solve this if I can't factor it?
It doesn't. Well, there's 2 imaginary for sure.
We did this, synthetic.
Oh, actually, this one's not going to be solved with synthetic division. The next one will. But you'll have to use the quadratic formula. If you get down to a quadratic that you can't factor, you use the quadratic formula. So, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative b plus or minus the square root. Alright, so there's my quadratic formula. Just plugging numbers in. So I'm going to have negative 4. Alright, so negative 4. Okay, so once I plug the numbers in, I'm just simplifying. So I simplified this, I did the 4 squared, and that's 136. So now I have negative 4 plus or minus the square root of 152 over 2. 152 can be broken down. Remember, we just simplified cube roots, so this is just a square root. So I'm going to break that down, 2 and 76, 2 and 38, 2 and 19. This is a square root. Now, somebody asked me last period, but I thought we were doing cubics. We are, but if you remember, we factored out that first x, and now we're dealing with a quadratic. So these are square roots that we're taking. So we're grouping in groups of 2. So there's a group of 2's, and these 2 are left alone. Groups go out, loners stay home, so that's going to be 2 square root 38. So that replaces the square root of 152. Is everybody okay? Remember this kind of? So negative 4 plus or minus 2 square root 38 over 2. Outside numbers simplify with outside numbers. Inside numbers do not. Inside numbers can only simplify with other inside numbers. But 2 goes into all of my outside pieces. So my final answer ends up being negative 2 plus or minus the square root of 38. Now, according to the fundamental theorem of algebra, I should have 3 answers because of this cube. And you do.
Because it's plus
Exactly. My 0 is 1, and then right here, because it's plus, that's one answer, and then the minus is the other answer. Now, let's plug it in our calculator and look at it. My calculator zoomed weird from the last problem, so I'm going to zoom 6 and get back to a standard window. Okay. Oh, well that's no good. I can't see it. It's too big. I'm going to zoom out. Actually, I'm just going to adjust my window. Okay, real quick, because I think adjusting your window is a kind of important thing. When you guys get to the SAT next, in a month or so, being able to zoom your window the right way is pretty valuable. So right here, I can see all 3 zeros. 1, 2, 3. What I can't see is the graph behavior because it's 2, but my x values are fine. So I don't need to make my x values any bigger. Does everybody understand what I'm saying? So when I go to adjust my window, all I need to adjust are my y values. It needs to go taller so that I can see the bumps, the bends on my graph. So I'm going to make it negative 50, positive 50, and just see if that works. Whoa, did I mess up? I must have hit something. Oh, but there's the bottom. Oh, I put 5. 50. I can definitely see the bottom now.
Still can't see the top.
Still can't see the top, so let's go adjust the top some more. Let's make it 100. And since I'm doing that, I'll change the count of pins.
Still can't see the top.
Still can't see the top. Darn it. Okay, let's make it 150. And since I'm doing that, I'll count by 20s.
Better.
Oh, it just barely fits in, but there it is. So now you can see it. Now, I still see all 3 zeros, just like I did a minute ago, but now it makes more sense in the context of the graph, because I can see the whole thing. But let's check our zeros. Now, obviously this one's 0. That's the first one we found, x equals 0, right there in the middle of the origin. But look at these other 2. They don't they're not exactly on grid lines. So I'm just going to look. I'm going to do second and trace. Find a 0, and since I'm closest to this one over here on the right, there's my cursor, I'm going to arrow over to it. So right now I'm left of it, so I hit enter, go right of it. Okay, so I get 4.16441. So now I'm going to go to my main screen, and I'm going to plug in this, the positive version, because it was on the positive side. Negative 2 plus the square root of 38. And there it is, 4.16441. Exactly what I got for that. It's just, this is a decimal approximation. This is an exact answer. So we would rather have exact answers, and a lot of times they're going to ask you specifically for exact answers. All right, so now look at number 6. Right upon looking at number 6, it is different than the first 3 we did. What is different about it? Can't factor it. You can't factor out an x. Because, number 1, it's got 4 terms, and the last term does not have an x on it. When you come across one like this, my suggestion is, because for right now, in Algebra 2, I let you use your calculator. My suggestion is, plug it in your calculator. If all 3 zeros are right on the grid lines, you're done. You don't have to do anything else. So let's try that and see if that works. Let's see. And you might want to zoom 6. Oh, you can see it actually in the... But I'm going to go back to my standard windows. Alright. When I go back to my standard window and I look at my graph, this one over here on the left not on a grid line. It's next to the grid line, but it's not on it. The one in the middle is not on a grid line. But the one on the far right is. Now, if you're not sure, you can go check your table. And remember, you're looking for zeros. I'm looking for where the y value is 0, and there's one right there, at 5. So I can go back and look at it and make sure that's the one I'm looking at. But it is, right there, 5. 1, 2, 3, 4, 5. It crosses right at an exact point. So now I know one of them. Now, here's where synthetic division comes in. Once you know that x equals 5, then I can put 5 in the corner. Coefficients across the top. 1, -5, -3. Jonathan, this is what we did yesterday, so you can watch the video. It's so easy. So you might be a little lost right now, but you'll be fine after you watch the video. Alright, my remainder came out to be 0, and it should have, because I know that x equals 5 is an answer. I got it off the calculator. So remember, you go 1 exponent down, so this is going to be x squared, this would be x, and that's your constant. So I end up with x squared minus 3 equals 0. Now right here, if I had a regular trinomial quadratic right here, I would factor it, but I don't. I actually have something easier. I can actually just move that 3 to the other side and take a square root. Now when you take a square root, how many answers are there? 2, positive and negative, square root 3. Now, I'm going to check in my calculator. I'm looking at zeros. There's my cursor. It is to the left of this 0. Now it's to the right. Okay, I got 1.732. Now, if I go to my main screen and do the square root of 3, I get 1.732. So that's this. So I have all 3 answers now. The one we first got off of our calculator, x equals 5, and then these 2. Positive square root 3 and negative square root 3. Now, if you had plugged it in your calculator and all 3 of them had been on exact grid lines, that would have been your 3 answers and you would have been done. You wouldn't have even had a synthetic grid line. It just, they didn't come out even this time. Alright, number 7, this is another easy one. What do I do?
Factor out an x.
Factor out an x. So I know one of the factors is 0. Anybody know how to factor that other thing? 4 and 4. X plus 4, x plus 4. Which means it's another double root, x equals -4. And that's all on those. Now there was one kind that it didn't get on this page because the back didn't print. So if you'll flip over to the back, I'm going to do one more for you. This is a review of something that we did the first semester, but it applies into this unit. So see if anybody remembers. Okay, so I get a cubic like this.
X plus 5, or x.
It's 3 is a triangle.
It does have, okay, so you guys y'all have a vague memory of it. Remember, this is the one with the small parentheses and the big parentheses. So I got a small set, and I got a big set. What sign goes in the small set?
The one that has.
It should have the same sign as the original, so it should have a minus. Now you take the cube root of both pieces. So the cube root of x cubed is x. What's the cube root of 125? 5. Now we square the first piece, put it in the first blank. Square the last piece, put it in the last blank. And then you multiply the 2 in the middle. Now remember, these have to have 2 pluses and a minus, so I need to add another plus there. Alright, so now I know one of my answers is x equals 5. This first one. But this one, I'm going to have to factor. Does it factor? No. 75 that combine to give you 5. So you're going to have to use the quadratic formula again. Negative b plus or minus the square root of b squared minus 4ac over 2a. Plugging in. Alright, I'm just simplifying now. Negative 5 plus or minus, what happens right here?
That confuses.
Yeah, it's going to be imaginary. But 75, I'm gonna come over here to the side and break down 75. 3 and 25, 5 and 5. Group of 5s, loner stays home. So this breaks down as negative 5 plus or minus. The 5's go out with the I. So it's going to be 5I, 3 inside. Nothing simplifies. Even though these two 5's are both 5's, because the 2 on bottom won't go into the 5's, you have to just leave it. So in this case, there's one answer, x equals 5 was the first one. And then there's your other two answers. They're these are what we call complex numbers. When you have an imaginary mixed with a real, these are called complex. Okay, so one other thing real quick. I'm going to copy back down the problem on number 6. Because there's multiple ways to do this. Synthetic division, which we learned yesterday, we use for polynomials. In Algebra 2, the state of Texas is requiring that we teach you cubics, but beyond that, all they wanted you to understand about polynomials is end behavior. You won't actually solve quartics and quintics until next year in pre-cal, and we use synthetic division to solve them. But most cubics can be solved by factoring, most of them. So in this case, I actually could factor this if you remember factoring by grouping. You factor the first two, group the second two, then you factor the first group as if it was all you could see. So what would I factor out of that?
2x.
X squared. So that would leave me x minus 5. Then I factored this group, negative 3. And that would leave me x minus 5. And you remember when you factor by grouping, these two pieces have to be the same. We would refer to them with a big W. Remember doing that? So then it was like x squared W minus 3W. What's the GCF of those? This went x minus 5, or the W, right? And we get x minus 3. And so that would give me x minus 5 and x minus 3. X squared minus 3. Those are your two factors. It's exactly the same thing that we got over here. So see, we found 5 from our calculator, and then we found x squared minus 3 synthetically divided. So you can, if you want to factor them by grouping, if you want to solve them by factoring by grouping, you're welcome to do that. Or you can use synthetic division. It doesn't make any difference because they get the same answer in the end. Synthetic division we will use a lot of in pre-cal next year. And then again in college algebra. There's a whole unit on polynomials in college algebra.
Can I go to this one?
Yes.
I prefer solving graphics.
Some of them, yeah. If you can plug them in your calculator. In order to synthetic